Hello, this is section 7.4, Solving Rational Equations. Part 1, Solving Equations with Fractions. To solve an equation with fractional coefficients, we first clear the denominators. We do this by multiplying by the LCD. Then solve the resulting equation. So example 1, solve the following equation. So I want to clear the denominators, so I need to find the LCD. And the LCD between 5 and 2 is 10. So now I'm going to multiply by 10 on both sides. Don't forget, because we're multiplying, you do have to use your distributive property. So then we get 10 times 3/5 equals 10 times 1/2 x plus 10 times 1. The 5 reduces the 10 to a 2. The 2 reduces the 10 to a 5. So we get 6 equals 5x plus 10. Subtract 10 from both sides. Negative 4 equals 5x. Divide by 5. Divide by 5. X equals negative 4/5. My recommendation before multiplying by the LCD is to distribute all parentheses first. Technically, that step doesn't need to be done, but I notice fewer mistakes are made if you do that step first. So in part B, I'm going to distribute the 1/6 first. So we get 1/6 x minus 3/6 equals 7 minus x over 12. So now that I get rid of the parentheses, I'm going to find the LCD, which is 12. I'm going to multiply both sides by 12. So we get 12 times 1/6 x minus 12 times 3/6 equals 12 times 7 minus 12 times x over 12. The 6 reduces the 12 to a 2, the 6 reduces the 12 to a 2, and the 12s just cancel out there. So we get 2x minus 6 equals 84 minus x. Add x to both sides, and add 6 to both sides. We get 3x equals 90. Divide by x, divide by x. We get x equals 30. And sorry, I made a silly error there. We didn't divide by x, we divided by 3. Part 2, solving rational equations. A rational equation is an equation that contains a rational expression. We can solve rational equations similarly to how we solve equations with fractions. And what that is you clear the denominators first, then solve the resulting equation. So for example 3, solve the following equations, part A. So find the LCD, which is 3x, multiply both sides by 3x. We get 3x times 7 over x minus 3x times 1 over 3x equals 8 over 3 times 3x. The x's cancel out, the 3x's cancel out, and the 3's cancel out. So we're left with 21 minus 1 equals 8x. So we get 20 equals 8x, divide by 8, divide by 8. We get 5/2 equals x. Now the one caveat is that whatever answer you get cannot make the denominators equal to 0. So what that means is if you plugged it into the least common denominator, that cannot equal 0. Well, if I plug 5/2 into the LCD, we get 3 times 5/2, which is 15/2, which is not equal to 0. So this is our answer. The reasoning for this last step is it is possible to get what are called extraneous solutions. Okay. Part B, well, the LCD here is x minus 2. So I'm going to multiply both sides by x minus 2. So we get x minus 2 times 5x over x minus 2 equals x minus 2 times 7 plus x minus 2 times 10 over x minus 2. So we get x minus 2's canceling out in both of the fractions. And we're left with 5x equals 7x minus 14 after we distribute that 7 plus 10. Subtract 7x from both sides. We get negative 2x is equal to negative 4. Divide by negative 2. Divide by negative 2. We get x equals 2. But now, when we plug that into the LCD, we get 2 minus 2. So we get 0, which equals 0. So that means this x equals 2 is not a solution. And since there were no other solutions, there is no solution to this equation. So that's the reason why you always have to plug it back in to the LCD to make sure that it doesn't make equals 0. When solving rational equations that have variables in the denominator, you must always check your answers. Such answers are called extraneous. When we use the LCD to clear denominators, the resulting equation could be quadratic. In these cases, we can use the zero product property and factoring to solve. Example 4. Solve the following equations. Make sure to check for extraneous solutions. Part A, so the LCD here is x plus 4 times x minus 1. So I'm going to multiply that by it. So we get x plus 4, x minus 1 times 2x over x plus 4 equals x plus 4 times x minus 1 times 3 over x minus 1. The x plus 4's cancel out here. The x minus 1's cancel out there. So we get 2x squared minus 2x equals 3x plus 12. So we do have a quadratic. So I am going to get 0 on one side in preparation for using the zero product property. So we get 2x squared minus 5x minus 12 equal to 0. And now I want to factor this. I am going to use the asterisk method over here to factor it. We get negative 24, negative 5, 2x, 2x. And then what two numbers multiply to negative 24 and add up to negative 5? Well, that's 3 and negative 8. Don't forget, if either of these fractions can be reduced, reduce it. So this can reduce to x over negative 4. So that means we get 2x plus 3 times x minus 4 equal to 0. Well, that means 2x plus 3 has to equal 0, or x minus 4 has to equal 0. Well, if you solve 2x plus 3 equal to 0, you get x equal to negative 3 halves. And if you solve x minus 4 equal to 0, you get x equals 4. Now, when I check whether these make the LCD equal 0, you will find that both of them are non-zero. So both of these are a solution. Part B, 1 minus 4 over y equals 12 over y squared. The LCD is y squared. So multiply everything by y squared. We get y squared times 1 minus y squared times 4 over y equals y squared times 12 over y squared. So you get y squared. That y cancels out one of those y's. So you get minus 4y. And then those two y squareds cancel out. And we get equal to 12. Again, to use the zero property, we need 0 on one side. So I'm going to subtract 12. Get y squared minus 4y minus 12 is equal to 0. Factor this with guess and check. We get y minus 6 times y plus 2 equal to 0. So you get y minus 6 equals 0, or y plus 2 equals 0. Solving each of those, we get y equals to 6 or negative 2. And now when I plug both of those back into LCD, neither of them equals 0, so they are both solutions. And I think this is a good place to stop for the first video, and we'll continue the rest in part 2.